Question 39. Aircraft flies a great circle track from 56 north to 62 north, and what is the total distance traveled? So see over here. We have one longitude 70 west. We have another longitude which is 110 east. The sum total is 180 degree. So that means both these locations are located on meridian and anti-meridian respectively, right? So when two locations are on meridian, anti-meridian, you will fly a great circle track joining them. And this great circle track will pass through the North Pole if they are in the northern hemisphere. So the diagram will look something like this. So draw the Earth. We have the North Pole here. We have 0 degree. We have 180 degree east and west, 90 east, 90 west. So first longitude is 70 west. 70 west. The other longitude is 110 east. So as you can see, both are directly opposite to each other. So that means one is located on meridian and another on its anti-meridian, right? So to go from this 70 west to 110 east, we will fly a great circle track, which is nothing but a combination of meridian and anti-meridian. And this great circle track will pass through the North Pole, and then you will reach on the other side of the hemisphere, which is point B. This is profitable. Okay, if you follow a rumline track like this in a circular manner, westerly or easterly, that will give you much more distance than the great circle track. So always follow the great circle track. So it will be something like this. North Pole, you are at 70 west, you have to go to 110 east. So now total DLAT, what is the difference between 90 degree and 70 degree west? It is 20 degree. The DLAT between 90 degree and 110, correction, 56 north, my bad. So we are going to pass through North Pole. So latitude to latitude, great circle track happens between two different latitudes. Okay. So this is 56 north, 70 west, 56 north, 70 west, and another is 62 north, 110 east. Now DLAT between 90 degree north and 56 degree north is how much? It is 36, right? 90 minus 56, 34. DLAT between 90 degree and 62 degree north is how much? 28 degree. Total DLAT is how much? 34 plus 28, which is 62 degree. So great circle distance will be DLAT in degree into 60, 62 into 60, which is equal to 3720 nautical miles. 3720 nautical miles. Option C is the correct answer. Let's go to understand this. When the sum of the longitudes is 180, you will do the sum this way. Formula is the same, but DLAT is how to find DLAT in the same manner, but from the North Pole. Okay. Position A and position B is given. Position A is 00 degree north, 100 degree east. Position B is 200 nautical miles from A, and you have to find the position of B. Yeah. So this was 39, this is 38. Okay, there was the sequence is wrong. So position A is given, position B is 240 degrees at a direction of 240 at a distance of 200 miles from A. What is the position of B? So let's take a new slide. Position A is at equator 00 degree north, longitude 100 degree east. Position B is at a direction of 240, at a direction of 240 degree, distance of 200 nautical miles from A. Okay, 200 nautical miles from A. So somewhere over here, position B is here, position A is here. So what is the position of B? Now see, when you are at the equator, you are at the equator and you are going in southwesterly direction. That means the new latitude of B will be a southern latitude, any southern latitude. The options given here are option A, northern latitude, option B, northern latitude. Option C is the only option which is a southern latitude, right? So option C will be the correct option. Next point. Your position A, longitude is 100 degree east and you are going in southwesterly direction. When you travel westerly direction in the eastern hemisphere, the values of longitudes decrease. So 100 degree east should decrease to some lesser value. But the options in A, option in B is 101, which is more than 100 degrees. So option B is totally eliminated in that way also. Only option A and C are the have longitudes less than 100 degrees. And out of that, we eliminate option A by checking the diagram and knowing that position B is actually to the south of A, not to the north of it. So we were able to eliminate option A. And this is how you solve this sum. Okay, and check the option C. So the correct option is option number C. Let's go to next question, question number 40. Position A is located on the equator at so and so longitude. Position B is located 100 miles from A at a heading of 225, bearing of 225. That is southwest direction. What are the final coordinates of B? So let's say we are position A is at equator, right? So this is your equator and this is where your A is situated. A is at 130 degree east, 00 degree north or south and 130 degree east, 130 degree east. And you are traveling in the direction of 225, which is nothing but southwesterly direction for a distance of 100 miles, distance of 100 nautical miles from A. You have to find position B, coordinates of position B. So A is here, B is here. So what are the final coordinates of B? So check this. You are going in southwesterly direction. That means the final latitude of position B must be a southern latitude, not northern latitude. So let's check the options if they have south latitude. So option A has southern latitude, option B has northern latitude, and option C also has southern latitude. So option B can be eliminated. Eliminate option B. Okay. Northern latitude is not possible. Now let's look at the longitudes. Now you are at 130 degree eastern longitude. When you travel in the direction of west and you are in the eastern hemisphere and you travel in the westerly direction, the values of longitudes decrease. Okay, they decrease. 130 will become 129, 128, 127, so on and so forth. So now your final longitude of B will be any longitude less than the value of 130 degree. So let's check any option has any value less than 130 degree. So option A has value of 128 less than 130. Okay. Option C has a value which is 131 more than 130. So we also eliminate option C, and the final option is option number A. Option number A. Okay. So just draw the diagram. When you draw the diagram, you will get the idea. So option A is the correct option, because what matters here is the direction which we are going in, southwesterly. So south denotes latitude, westerly will be helpful to find a suitable longitude. Okay. 41. Aeroplane was to circle around the earth 360-degree rotation at latitude 60° north at a speed of 480 knots. In order to circle around the earth at equator, previously you were circling at 60° north, and now you are circling at equator in the same amount of time. What will be your new speed? Okay, so look at this. Now this is your earth. The shape of the earth is something like this. It is bulging at the equator. That means the distance around the equator is much more than the distance at 60° north latitude is much more than the distance at 60° north latitude. The distance you will cover to make a full 360-degree rotation at equator is much more than the distance you cover at 60° north latitude. So let's find the distance. Now at 60° north you are traveling at 480 knots speed. The distance, now this will be a rumline distance along a given parallel of latitude. D long in minutes into cos lat. So D long is how much you are making a full 360-degree turn. So 360° into 60 minutes into cos of 60. 360 into 60 into half. So that will be equal to 10,800 nautical miles. So the total distance you will cover when you circle a 360-degree rotation at 60° latitude is 10,800 miles. Now distance is 10,800. The speed at which you will rotate 360° is 480 knots. The time you will take will be how much? 10,800 divided by speed 480. This time will be 22 hours 30 minutes, 22.5 hours. 22.5 hours. So the time you take to circle full 60° north latitude is 22.5 hours. Now you have to circle equator, 0° north south equator, full 360° in same time. In same time you have to cover a much more distance at equator. So what will be your new speed? It will be definitely more than the speed over here. Over here the speed was 480. At equator it should be more than 480 because the distance you have to cover at equator is more, but the time is the same. So it should be more than 480. More than 480 means eliminate option B. Remaining options are 550 and 960. So the distance at equator is D long into cos latitude. 360 into 60 into cos of 0. So 360 into 60 is how much? 21,600. Cos 0 is 1. So distance is you have at equator 21,600. Time you have 22.5. Speed will be 21,600 divided by 22.5. So 960 knot. 960 knot. Okay. So the correct option will be option Charlie 960. Simple. So find the distance at 60° latitude. Find the time. With that time, find the distance at equator and then speed at equator. Let's go to next question, question 42. In order to fly A to B, maintaining a constant track, so that means they are talking about rhumb line. It is necessary to fly what? So you're going from A is at 10° north and 30° west, 10° north, 30° west, and B is at 30° north and 50° west. Okay, and you have to fly from A to B like this. You have to fly like this from this point to this point. And the condition they have stated is the track should be a constant course. By definition, the correct option will be a great circle, a rhumb line track correction. Okay, rhumb line track is any track or a line with a constant direction. So if they have given this condition that the track should be constant, we will fly a rhumb line track. So with this, we come to the end of this good lecture. I hope you have understood everything. You have learned something new today, and now you're comfortable solving departure questions. Do watch the videos I have made on departure questions in Oxford GenNav. I will put the link in the description box. Like button, you have to hit it like every time. Subscribe to this channel without fail, and to share this video with all your friends. Let me know your questions, your doubts, your feedback in the comment box. All the best. Keep learning.